To tear a human body away from the gravitational grip of Earth, you need to ignite thousands of tons of highly explosive chemical propellants. You have to accelerate a fragile metal tube to a speed of roughly 24,000 miles per hour. If your trajectory is off by a fraction of a single degree, you do not just miss your target. You do not get a second chance to course correct. You become a permanent, silent ghost drifting through the frozen graveyard of the inner solar system. Physics does not forgive. The vacuum does not negotiate. The margins of survival in deep space are so impossibly thin that a single microscopic flaw in a heat shield or a tiny frozen valve can instantly turn a triumphant historical moment into an absolute tragedy. For over half a century, 52 years, to be mathematically exact, humanity has stayed quietly in the shallow end of the cosmic pool. Low Earth orbit, safe, close to home. We built space stations, but we never truly went back into the deep, dark water. But we were told that era of caution was finally ending. We were promised a grand return. The National Aeronautics and Space Administration spent billions of dollars and over a decade building the most powerful rocket in human history. The goal was crystal clear. The timeline was rigidly set. The Artemis program was supposed to put humans back on the harsh surface of the moon by the year 2025. It was presented to the public as an absolute certainty, and then, in the early months of the year 2024, everything shifted. The timeline cracked. The highly anticipated lunar landing was quietly scrubbed from the immediate schedule. It was pushed deeper into an uncertain future. The mission profile for Artemis III, the specific flight meant to finally touch the lunar dust again, was silently downgraded. Instead of a triumphant landing, it has turned into just another cautious test flight. The official press releases gave us the usual, easily digestible reasons: supply chain issues, hardware delays, budget constraints, normal bureaucratic hurdles. But the cold reality of orbital mechanics and deep space architecture tells a much darker, far more complicated story. When an agency that successfully landed men on the moon back in the 1960s, using computer technology infinitely weaker than a modern smartphone, suddenly stalls today, you have to ask what exactly they are running into. The vacuum of space has not changed. The physical distance to the moon is exactly the same as it was during the Apollo missions. What changed is the understanding of the danger. There is an invisible, lethal wall we hit the moment we try to leave our planetary cradle in the modern era. A barrier of deep space radiation, mind-bending, orbital complexity, and sheer technological terror that the space industry is only now beginning to fully admit to itself. The sudden delay of the Artemis landing is not just a simple scheduling conflict. It is a glaring symptom of a massive, quiet crisis. Something deep within the heavily guarded architecture of the mission triggered a profound alarm. When we watch a modern rocket launch on our high-definition screens, our brains inevitably trick us. We see a sleek, perfectly painted machine rising smoothly on a pillar of bright fire, and we instinctively compare it to a commercial airplane taking off from a runway. We are wired by our everyday, comfortable experiences on Earth to believe that space travel is just the next logical step in transportation. You pack your necessary supplies, you ignite the main engine, you point the vehicle at your cosmic destination, and you simply hit the gas until you arrive. This is the first massive lie of human intuition. Spaceflight is absolutely nothing like flying. An airplane is essentially swimming in an ocean of thick air. It uses the atmosphere to generate physical lift. It pushes against the wind, riding the currents of our sky. But a rocket is fighting a completely different, much more violent war. It is not swimming, it is violently tearing itself out of a massive, invisible, gravitational pit. We call it a gravity well, and Earth has an incredibly deep, unforgiving well. Imagine for a moment the sheer physical toll of human endurance. Think about the intense burning in your lungs when you push yourself to the absolute limit, like pushing your body to run continuously, fighting for every single breath, crossing that grueling 90-second mark of a sprint where your heart pounds aggressively in your ears and every single muscle screams at you to just stop moving. Now, translate that pure, agonizing physical effort into thousands of tons of metal and explosive chemical fire. A spacecraft is essentially doing that exact same brutal sprint, but it is fighting against the crushing, relentless weight of an entire planet pulling it backward. The universe does not care about our advanced engineering degrees. It does not read our text. It does not care about our human letters, and it is entirely unimpressed by our mathematics. It only obeys the cold, absolute geometry of mass and gravity. This brings us to a terrifying physical barrier known as the tyranny of the rocket equation. It is widely considered the cruelest rule in astrophysics. If you want to put a tiny metal capsule containing 3 fragile humans into the cold vacuum of space, you need fuel. A massive, almost incomprehensible amount of it. But liquid fuel is extremely heavy. So, in order to lift the fuel that lifts the human astronauts, you need even more fuel just to carry the first batch of fuel. And to lift that extra weight, you need another set of massive structural tanks filled with even more explosive liquid. It is a vicious, compounding cycle of mass. By the time you build a machine capable of actually leaving the grip of the Earth, roughly 99% of the entire towering structure is literally just a giant, highly volatile bomb designed for the sole purpose of throwing the remaining 1% into the dark void. You are not piloting a ship. You are essentially riding a continuous, carefully controlled explosion. If you are off by a fraction of a single second during that ascent, the physics of the atmosphere punishes you with absolute, immediate destruction. And even if you survive that terrifying pillar of fire, you immediately crash into the next massive misunderstanding of our common sense. The concept of orbit. Most people comfortably assume that to stay up in space, you just fly high enough until the gravity of the Earth simply stops working. They watch astronauts floating inside their pristine white cabins and believe they are outside the magnetic pole of the planet. That is completely, fundamentally wrong. At the altitude of the International Space Station, the gravitational pull of the Earth is still nearly 90% as strong as it is right down here on the ground. If you simply climbed a ridiculously tall ladder to that exact height and let go, you would plummet straight back down through the clouds and crash into the surface. To stay in space, you do not just go up, you have to go sideways, violently fast. You have to accelerate your spacecraft to a speed so blindingly fast, roughly 17,500 miles per hour, that, as gravity desperately pulls you back down toward the ground, the curved surface of the Earth actually bends away beneath you. You are not magically floating. You are constantly, permanently falling. You are just moving so incredibly fast, horizontally, that you continuously miss the ground entirely. It is a delicate, terrifying, high-wire act of momentum and orbital mechanics. And that staggering speed is required just to stay in low Earth orbit. the absolute safest, closest parking spot in the cosmic void. But the Artemis missions are not trying to park in the safe driveway. They are trying to cross the black ocean. They are trying to reach the desolate surface of the moon. And this is exactly where our human brains completely fail to comprehend the sheer scale of the nightmare we are dealing with. When you step outside and look up at the night sky, the moon looks relatively close. It looks like a bright lantern just hovering right above the edge of the atmosphere. We have been conditioned by decades of science fiction movies and television shows to think of the Earth and the moon as two friendly neighbors sitting right next to each other. The reality is a vast, empty, terrifying horror. The physical distance between our warm blue planet and the dead rock of the moon is roughly 238,000 miles. That number is so incredibly large that it becomes completely meaningless to our terrestrial minds. So let us break it down into a visual anomaly that you can actually process. If you took every single planet in our entire solar system, Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune, you could line them all up, side by side, edge to edge, like beads on a string, and they would perfectly fit inside the empty, silent gap between the Earth and the Moon. There is absolutely nothing but cold, irradiated, hostile nothingness in that colossal expanse. When you send a tiny crew of human beings across that terrifying void, they are fundamentally severed from the safety net of our world. Think of it in terms of a massive interplanetary network architecture. Down here, Earth is the central server. It processes all the heavy data, holds all the critical life support resources, and makes all the vital decisions. The spacecraft, hurling toward the moon, is an isolated client system, pushed out to the absolute darkest edge of the network. On Earth, if a local system fails, the client simply sends a quick request to the server, and the server instantly provides a fix. The latency is practically zero, but out there in deep space, that connection stretches, warps, and degrades. It takes actual time for a radio signal, traveling at the absolute maximum speed of light, to cross that monstrous abyss. If something critical breaks on a spacecraft halfway to the lunar surface, if a single oxygen valve freezes shut or a navigation circuit board shorts out, the crew cannot just wait for mission control to actively save them. The delay is fatal. The isolated client must survive on its own, surrounded by an environment actively trying to kill it. This brings us directly back to the great historical mystery that haunts the modern space industry. If leaving Earth is this incredibly difficult, and the distance is this terrifyingly dangerous, how on earth did humanity accomplish this back in 1969? We look at the grainy, highly degraded black and white footage of the Apollo astronauts playfully bouncing on the gray lunar dust, and we assume we conquered this cosmic beast a long time ago. We think the complex problem of lunar travel was completely solved before most of us were even born. But the truth is, the Apollo program was never a sustainable, long-term model for space exploration. It was a brutal, brute force, engineering miracle born out of pure Cold War desperation. The National Aeronautics and Space Administration essentially threw an unlimited mountain of money, raw analog engineering, and reckless human bravery at the physical barrier until they forcibly smashed through it. They took calculated risks that absolutely no modern space agency would ever be legally allowed to take today. They strapped highly trained men to the very top of the Saturn V rocket, a machine so immensely powerful and so incredibly loud that the acoustic sound waves alone could literally melt concrete and tear human tissue apart at the launch pad. The walls of the Apollo lunar lander were manufactured so unbelievably thin that an astronaut could literally punch a hole straight through the metal hull with a standard screwdriver. They survived by the absolute skin of their teeth. And then, the moment the political race was conclusively won, we simply stopped. We stopped building those massive, raw machines. The specialized factories were entirely shut down. The incredibly complex supply chains were dismantled and sold off for scrap. The veteran engineers, who understood the highly specific, undocumented quirks of those ancient analog systems, slowly retired and passed away. We did not just casually stop going to the moon. Over the span of 5 decades, we actively unlearned how to get there. So now, in the 2020s, despite all of our touchscreens and artificial intelligence, we are essentially starting from scratch when it comes to deep space survival. We have spent years building an entirely new architecture, a new rocket known as the Space Launch System. It is an absolute monster of modern manufacturing. It is taller than a commercial skyscraper and packed tightly with the most advanced, hyper-intelligent flight computers ever designed by human hands. It looks entirely perfect on paper. The complex mathematics work. The digital simulations are flawlessly clean, but a computer simulation is not reality. A simulation does not actually suffer the microscopic, unpredictable chaos of deep space. As the agency prepared to finally put fragile human lives back into this new, untested lunar architecture for the Artemis missions, they realized a dark truth. While our silicon computers have gotten infinitely smarter, our biological bodies have not changed at all. We are just as vulnerable to the void as we were 50 years ago, and deep space, the environment itself, is hiding a violent, invisible threat that the original Apollo missions barely dodged by sheer, blind luck. A threat that makes returning to the lunar surface not just a matter of building a bigger rocket, but a matter of surviving a relentless onslaught that our modern, highly sensitive digital technology is ironically terrified of. The sudden delay of Artemis III is not a simple hardware glitch or a scheduling mistake. It is the chilling, sudden realization that the path back to the moon is heavily guarded, and humanity is currently trying to figure out how to survive a lethal environment we did not even know was truly there. The universe is vastly more hostile than we ever wanted to admit, and the real reason humanity has been trapped in low orbit is a dark secret written in the very physics of the cosmos. If you seek the truth in the dark, subscribe and join us on this journey, because the deeper we push into the vacuum, the more terrifying the answers become. To truly understand the invisible barrier that is currently keeping us trapped close to home, we have to look at the very nature of the planet we live on. We walk around every single day completely oblivious to the fact that we are living inside a massive, heavily fortified cosmic bunker. Deep beneath your feet, about 1,800 miles down, the Earth possesses a churning, spinning core of liquid iron. This incredibly violent underground ocean of molten metal generates a massive invisible magnetic field that violently projects outward, wrapping the entire globe in a protective bubble. We call this bubble the magnetosphere. You cannot see it, you cannot smell it, you cannot feel it against your skin. But if that invisible magnetic shield were to suddenly turn off for even a few hours, life on the surface of our world would be completely and utterly sterilized, because space is not just empty. It is not a quiet, peaceful vacuum waiting to be explored. It is a highly active, heavily irradiated war zone. Our sun, the warm yellow star that gives us daylight and grows our crops, is actually a raging, unpredictable nuclear reactor. It is constantly boiling, constantly churning, and constantly firing a relentless hurricane of highly charged radioactive particles in every single direction. This is the solar wind. Right now, as you listen to this, that lethal wind is slamming against the invisible magnetic shield of the Earth at roughly 1 million miles per hour. The shield catches this deadly radiation, deflects it, and channels it safely around the planet, harmlessly tossing it deep into the empty void behind us. Down here, on the ground, we are completely safe. Even the astronauts living aboard the International Space Station are safe, because the space station orbits the Earth at a height of roughly 250 miles. That might sound very high up, but on a cosmic scale, it is barely skimming the surface. It is still tucked safely, deeply inside the warm, protective embrace of the magnetic bunker. But to reach the moon, you have to leave the bunker. You have to completely cross that invisible line of safety. And the moment a spacecraft pushes its nose past the outer edge of the Earth's magnetic field, it enters an environment of pure, unfiltered hostility. The first massive hurdle is not just outside the shield, it is actually trapped within the shield itself. As the Earth catches all that deadly radiation from the Sun, it acts like a giant cosmic magnet, trapping billions of highly energized particles in two massive donut-shaped rings of intense radiation that completely encircle the equator of the planet. These are the Van Allen radiation belts. Think of them as two incredibly deep, wide moats surrounding a medieval castle, but instead of water, they are filled entirely with invisible, raging nuclear fire. When the Apollo astronauts flew to the moon in the 1960s and 70s, they did not have any magical technology to disable these belts. They simply had to close their eyes, push the throttle to the absolute maximum, and drive straight through the fire as fast as physically possible. They minimized their time inside the belts to limit the damage to their bodies. It was a terrifying, high-speed gamble. You go in fast, you take a small dose of radiation, and you hope you punch through to the other side before the invisible bullets cause any permanent, fatal damage to your cells. But passing through the Van Allen belts is only the beginning of the nightmare. Once you finally break free from the magnetic grip of the Earth, you are out in the deep, dark ocean. You are completely exposed. Out in deep space, there are two distinct, incredibly lethal types of radiation waiting for you. And understanding how they work is the absolute key to understanding the dark secret of the Artemis delays. The first major threat comes directly from our own sun. It is called a solar particle event. Every now and then, the complex magnetic fields on the surface of the sun become twisted and tangled. They build up an unimaginable amount of tension, like a colossal rubber band being stretched to its absolute breaking point. When that magnetic rubber band finally snaps, the explosion is practically incomprehensible. The sun violently vomits a massive cloud of boiling plasma and deeply penetrating radiation straight out into the solar system. This is a solar storm. If a spacecraft happens to be caught in the direct path of one of these storms while traveling to the moon, the consequences are immediate and brutal. The particles hit the metal hull of the ship at a significant fraction of the speed of light. To the fragile human body inside, this is completely devastating. You cannot simply hide behind a thin wall of aluminum. The radioactive particles crash into the metal of the ship and shatter, creating a secondary shower of microscopic shrapnel that tears directly through human tissue. It is like being put inside a microwave that has been turned on from the outside. the astronauts would quickly experience severe nausea, violent vomiting, total fatigue, and the rapid destruction of their bone marrow without massive, heavy lead shielding, which we already know is physically impossible to launch because rockets cannot carry that much weight. A severe solar storm is a guaranteed death sentence. And the terrifying truth about the Apollo missions, the reality that the space agencies rarely ever talk about in public, is that we were saved by pure, blind, unbelievable luck. The Apollo missions only lasted a few days. They were incredibly short sprints to the moon and back. The astronauts went up, planted a flag, grabbed some rocks, and sprinted back to the safety of the Earth before the sun had a chance to get angry. But the timing was razor thin. In August of the year 1972, right in the middle of the Apollo program, exactly between the flights of Apollo 16 and Apollo 17, the sun unleashed one of the most violent, massive solar storms ever recorded in modern history. It was an absolute monster. A wave of lethal energy swept across the exact path between the Earth and the Moon. If there had been an Apollo crew in space during that exact week, floating in their thin metal capsule or walking around the lunar surface in their fragile cloth suits, they would have absorbed a lethal dose of radiation within a matter of hours. They would have died a very painful, very tragic death in the cold vacuum, and the entire history of human space exploration would have stopped dead in its tracks. We did not conquer the radiation in the 1960s. We essentially played a cosmic game of Russian roulette, and the chamber just happened to be empty when we pulled the trigger. But you cannot build a permanent, long-term lunar base based entirely on blind luck. The Artemis program is not just trying to visit the moon for a quick weekend camping trip. The National Aeronautics and Space Administration wants to build a permanent orbital station around the moon. They want astronauts to live and work in the lunar dust for weeks, and eventually for months at a time. You cannot outrun a solar storm if you are living right in the middle of the desert. Eventually, the storm will hit you. And yet, the sun is only half of the problem. Because even if the sun is perfectly quiet, even if there are absolutely no solar flares for an entire year, the deep space environment is completely saturated with something far worse and far more sinister: galactic cosmic rays. These are not generated by our local sun. These are the violent, ancient ghosts of the entire universe. Millions, sometimes billions of years ago, massive, dying stars in distant alien galaxies exploded in terrifying supernovas. Black holes tore entire solar systems apart. These unimaginable cosmic events accelerated heavy, dense atomic core to nearly the absolute speed of light. These microscopic bullets have been traveling across the cold, silent void of the universe for millions of years. And right now, millions of them are aggressively passing through our solar system from every conceivable direction. They are heavy, they are fast, and they are completely unstoppable. When a galactic cosmic ray hits a human cell, it does not just damage it, it acts like a microscopic cannonball, tearing straight through a carefully constructed house of cards. It aggressively, physically severs the delicate double helix structure of human biological coding. It breaks the very fundamental instructions of our DNA. If you spend enough time out in deep space, bombarded by these ancient, unstoppable particles, your risk of developing massive, incurable cancers skyrockets to a terrifying degree. It damages the central nervous system. It permanently impairs cognitive brain function. This is the silent, invisible radiation wall that makes long-term spaceflight an absolute nightmare for biologists. But here is where the story takes a truly bizarre, deeply ironic twist. You might be thinking, if the radiation is this incredibly dangerous, how did the Apollo hardware survive? How did the computers on the Saturn V rocket manage to fly perfectly straight while being bombarded by all these cosmic rays? The answer is both hilarious and deeply troubling for our modern engineers. The Apollo computers survived because they were incredibly, wonderfully stupid. The flight computers used in the 1960s were entirely analog. The electrical wires inside them were physically thick. The circuits were completely massive by modern standards. When a galactic cosmic ray tore through an Apollo computer, it just passed straight through the giant, bulky wires without doing anything. The electrical pathways were simply too big to care about a microscopic disturbance. It was like throwing a single grain of sand at a massive, heavily armored tank. The tank does not even notice. But today, human technology has evolved in a completely different direction. We have spent the last 50 years making our computers smaller, faster, and infinitely more complex. The modern microchip inside your smartphone or your laptop has billions of microscopic transistors packed onto a tiny square of silicon. These modern transistors are so impossibly small that they operate on the absolute edge of atomic physics. They hold incredibly tiny electrical charges to represent ones and zeros, the binary language of our modern world. And this incredibly advanced, highly delicate miniaturization has turned our modern spacecraft into fragile glass houses floating in a hailstorm. When a heavily charged cosmic ray passes through a modern, state-of-the-art flight computer in deep space, it carries enough raw electrical energy to completely flip a 0 into a 1. This is an actual, deeply terrifying phenomenon known in the space industry as a single-event upset. It sounds like a minor technical glitch, but the consequences are absolutely catastrophic. Imagine a massive, towering rocket hurling toward the moon at thousands of miles per hour. The flight computer is carefully calculating the exact trajectory using millions of lines of code. Suddenly, an invisible, ancient particle from an exploded star millions of light years away passes directly through the processor. It flips a single, tiny bit of memory from a 0 to a 1. Instantly, the computer thinks the rocket is violently off course. The navigation system panics. It aggressively fires the thrusters to correct a mistake that never actually happened. Within seconds, the highly advanced, multi-billion-dollar spacecraft throws itself into a fatal, uncontrollable spin, tearing itself apart in the cold vacuum, all because of a single, invisible, microscopic particle. Our greatest technological strength on Earth, our ability to build incredibly small, highly intelligent computers, has become our absolute greatest, most terrifying weakness in deep space. We built machines that are simply too smart, too sensitive, and too delicate to survive the brutal, crude reality of the cosmic ocean. To prevent these microscopic disasters, modern engineers have to design ridiculously complicated, heavy, and extremely expensive systems. The computers on the Artemis spacecraft do not just calculate their path once. They have multiple, entirely separate computers running the exact same calculations at the exact same time. They constantly talk to each other. They constantly check each other's math. If one computer gets hit by a cosmic ray and suddenly hallucinates a wrong number, the other computers outvote it, ignore the corrupted data, and force the system to reboot. It is a constant, desperate, endless war against the invisible elements of the universe. And in late 2022, the space agency finally launched Artemis I. It was a completely uncrewed test flight. The massive new rocket lifted off, pushed the new Orion capsule out of the Earth's orbit, and sent it on a lonely, silent journey completely around the moon and back. There were no human lives at risk on this flight. But inside the capsule, strapped tightly into the commander's seat, the agency placed complex mannequins packed aggressively with thousands of highly sensitive radiation sensors. The goal was absolutely critical. They needed to measure exactly what the modern deep space environment would do to a human body and a modern computer system before they dared to put real, breathing astronauts inside. They needed real, hard data on the Van Allen belts. They needed concrete measurements on the galactic cosmic rays. They needed to see exactly how their hyper-advanced, incredibly sensitive microchips would hold up under the relentless, invisible bombardment of the void. The capsule flew beautifully. The cameras sent back stunning, crisp, high-definition videos of the moon that captivated the entire world. The public relations team celebrated a massive, historic victory. It looked like the golden age of space exploration had finally returned. But when the capsule splashed down violently in the cold waters of the Pacific Ocean, and the engineers finally cracked open the hatch to extract the data from those silent, heavily irradiated mannequins, the numbers they pulled out of the sensors did not lead to a celebration. The raw data painted a picture of an environment that was significantly more chaotic, significantly more dangerous, and vastly more unpredictable than their clean, perfect digital simulations had promised. They realized that the protective shielding of the new capsule, the heavy, complex systems designed to keep human beings alive and computers perfectly sane, was hiding a massive, terrifying flaw. A flaw that fundamentally threatened to completely unravel the entire timeline of the human return to the lunar surface. When the Artemis I capsule was finally pulled from the cold waters of the Pacific Ocean, the public relations cameras carefully focused on the pristine upper half of the spacecraft. It looked like a flawless victory. The white panels were clean. The mission was loudly declared an absolute triumph. But behind heavily closed doors, away from the cheering crowds and the live internet broadcasts, the engineering teams were looking at the bottom of the ship. They were looking at the heat shield, and what they saw sent a cold, terrifying shockwave through the entire architecture of the Artemis program. To understand why a few scorch marks on a metal dish could single-handedly paralyze the most powerful space agency on the planet, you have to understand the most violent, unforgiving physical process in all of spaceflight reentry. When a spacecraft is returning from the moon, it is not simply floating back down to Earth. It does not gently glide. It is effectively a massive, metallic meteor falling down an incredibly deep gravitational pit. By the time the capsule reaches the outer edge of our atmosphere, it has been accelerating non-stop for 3 entire days. It is traveling at a speed of roughly 24,500 miles per hour. That number is so large it becomes abstract, so let us ground it in reality. That is roughly 32 times the speed of sound. At that blinding velocity, you could cross the entire continental United States in a matter of minutes, and in the cold vacuum of space, you do not have brakes. There is absolutely no physical friction to slow you down. You cannot fire your rockets in reverse because you have already burned all of your fuel just to get to the moon in the first place. The only way to stop, the only way to avoid smashing into the ground like a ballistic missile, is to intentionally crash your fragile metal capsule into the thick wall of the Earth's atmosphere. You use the air itself as a giant, brutal brake pedal. Most people instinctively believe that when a spacecraft re-enters the atmosphere, it gets hot because of friction. They think the air is rubbing against the sides of the ship, like rubbing your hands together rapidly to create warmth. That is another massive failure of our common sense. Friction has almost nothing to do with it. The reality is far more violent. It is a process called atmospheric compression. Imagine taking a simple bicycle tire pump. If you put your thumb over the nozzle and push the handle down violently, the bottom of the pump gets incredibly hot. The heat does not come from the plunger rubbing against the sides. The heat comes from the fact that you are forcibly crushing the air molecules together into a tiny space. When you compress a gas, its temperature rises exponentially. Now, imagine that same concept, but scaled up to a monstrous planetary level. The capsule is hitting the upper atmosphere so incredibly fast that the air molecules in front of it simply cannot get out of the way. The spacecraft acts like a colossal piston, violently crushing the thin air directly against the blunt bottom of the heat shield. The air is compressed so fast and so brutally that the physical laws of normal thermodynamics begin to break down entirely. The gas does not just get hot, it literally tears itself apart at an atomic level. The electrons are violently ripped away from their atoms. The air itself ceases to be a gas and transforms into a blindingly bright, superheated state of matter known as a plasma. The spacecraft is suddenly enveloped in a raging, artificial sun. The temperature of this plasma shockwave, positioned just a few inches from the bottom of the heat shield, reaches roughly 5,000 degrees Fahrenheit. That is more than hot enough to instantly melt solid steel into a bubbling liquid. It is hot enough to incinerate human bone and turn the complex computer systems inside the ship into a puddle of useless, dripping slag. The only thing standing between the fragile, squishy human astronauts and this apocalyptic wall of fire is the heat shield. But a heat shield does not work like a thick blanket. It cannot simply block the heat, because eventually the heat would soak entirely through the material and bake the crew alive from the inside out. Instead, the heat shield relies on a brilliant, desperate process called ablation. The bottom of the spacecraft is coated with an incredibly thick layer of specialized resin. As the 5,000-degree plasma slams into the shield, this resin is intentionally designed to burn. It is designed to melt, vaporize, and violently boil away into the slipstream. As the material boils away, it carries the intense heat with it, pulling the thermal energy away from the metal hull of the ship. The shield literally sacrifices its own physical mass, dying piece by piece, to keep the interior of the cabin perfectly cool. It is a terrifying, highly controlled process of self-destruction, and for 50 years it worked beautifully. But the new Artemis capsule, the Orion spacecraft, is significantly heavier and much larger than the old Apollo capsules. Because it is heavier, it carries vastly more kinetic energy, and the laws of physics dictate that energy does not scale linearly. If you double the weight or double the speed, the amount of heat generated during re-entry multiplies exponentially. To deal with this massive increase in thermal energy, the modern engineers attempted a highly complex, incredibly dangerous new maneuver. Instead of plunging straight down through the atmosphere like a falling stone, the Orion capsule was designed to skip. It hits the upper atmosphere, compresses the air, generates a massive wall of plasma, and uses the aerodynamic lift to literally bounce back out into the freezing, empty vacuum of space. It skims the top of the sky exactly like a flat rock skipping across a quiet pond. By bouncing back into space for a few moments, the spacecraft sheds a massive amount of speed. and the heat shield gets a brief, vital window to cool down in the absolute zero temperatures of the void. Then, it plunges back into the atmosphere for a second, final dive, completely bleeding off the rest of its momentum until the parachutes can safely deploy. It is a masterpiece of orbital mathematics, a beautifully choreographed dance between gravity, aerodynamics, and thermodynamics. In the digital simulations, it worked with absolute, flawless perfection. But when the engineers finally looked at the actual heat shield of the Artemis I capsule after its silent journey, the simulation shattered. The shield had not burned away smoothly. It had not sacrificed its material in a controlled, predictable layer. Instead, the extreme thermal shock of the skip maneuver, plunging from the freezing vacuum of space directly into a 5,000-degree plasma fire, and then violently back into the freezing vacuum within a matter of minutes, had caused the specialized resin to panic. The material did not just melt, it cracked, it fractured. Entire chunks of the heat shield had violently sheared off and flown away into the wind, leaving deep, terrifying gouges in the bottom of the spacecraft. In some areas, there was significantly more material missing than the computer models had ever predicted in their absolute worst-case scenarios. This is the great, silent terror that forced the delay of the Artemis missions. In a completely uncrewed test flight, a scarred heat shield is just an interesting data point. It is a learning opportunity. But Artemis II, the mission they suddenly delayed, is completely different. Artemis II is supposed to carry for living, breathing human beings. If a large chunk of the heat shield prematurely breaks away while human astronauts are strapped inside, the 5,000-degree plasma will instantly find that weak spot. It will act like a hyper-pressurized blowtorch, burning a clean, immediate hole straight through the metal floor of the cabin. The crew would not even have time to scream. The atmosphere inside the capsule would instantly ignite, and the entire spacecraft would disintegrate into a shower of burning metal, scattered across hundreds of miles of the upper atmosphere. You cannot ignore a flaw in a heat shield. You cannot negotiate with 5,000 degrees of plasma. So, human logic immediately offers a simple, obvious solution. If the shield is losing too much material, just make the shield thicker. Add more resin. Make it stronger. But out here, in the brutal reality of orbital mechanics, the simple solution is always a trap. This brings us violently back to the absolute darkest, most unforgiving rule of the universe, the tyranny of the rocket equation, the mass budget. The Space Launch System, the massive rocket designed to carry the Orion capsule, has a strictly defined, absolute maximum weight limit. The engineers cannot add a single ounce of weight without violating the rigid laws of physics that allow the rocket to break free from the Earth's gravity. The mass budget is already completely full. The rocket is maxed out. If the thermal engineers demand that they add 500 pounds of heavy resin to the heat shield to guarantee the safety of the crew, they cannot just add it. They have to steal that weight from somewhere else. If you add 500 pounds to the bottom of the ship, you must entirely remove 500 pounds from the inside of the ship. But what exactly do you take away? Do you remove the backup navigation computer? If you do that, and the primary computer is destroyed by a microscopic cosmic ray, the crew drifts into deep space and dies. Do you remove 500 pounds of drinking water? If you do that, the crew dies of severe dehydration before they even reach the dark side of the moon. Do you remove the heavy lead lining that protects the electronic systems from the violent solar storms? Every single pound on that spacecraft is completely accounted for. Every piece of equipment is absolutely critical for keeping human bodies alive in a terrifying vacuum that desperately wants them dead. And this is where the paradox becomes incredibly grim, because Artemis II is the very first mission that actually requires a fully functioning environmental control and life support system. During the uncrewed Artemis I mission, the capsule was essentially a cold, dead, empty room. But humans are an absolute nightmare to transport. We are incredibly messy, fragile biological machines. We constantly consume heavy resources, and we constantly produce toxic waste. Every single time an astronaut exhales, they dump carbon dioxide directly into the sealed cabin. In a small, airtight room, carbon dioxide builds up incredibly fast. It is a heavy, invisible, silent killer. If the air is not constantly scrubbed and chemically filtered, the astronauts will quietly go to sleep and simply never wake up. Human bodies also radiate massive amounts of ambient heat. We sweat. We add dangerous levels of biological humidity to the air. In zero gravity, that sweat does not simply drip to the floor. It floats around the cabin like tiny, microscopic water balloons, migrating directly into the sensitive electronic circuit boards, shorting them out and causing catastrophic electrical fires. To keep 4 human beings alive for 10 days, the Orion capsule is packed completely full of heavy pumps, thick fluid lines, massive chemical scrubbers, and giant spinning fans. This entire life support network is an incredibly heavy, monstrously complex beast, and it draws an immense amount of electrical power from the solar panels. If the heat shield requires more mass to survive the plasma, the engineers might be forced to scale back the redundancy of the life support systems. This is the agonizing, impossible tug-of-war happening right now behind the closed doors of the space agency. It is a vicious, closed-loop paradox. You need a thicker shield to survive the landing. But a thicker shield requires a lighter life support system. A lighter life support system vastly increases the risk of the crew suffocating in the vacuum. If you want a heavier life support system and a thicker shield, you need a bigger rocket. But the rocket is already built, and building a bigger one would take another 20 years and $50 billion. They are entirely trapped in a mathematical corner by the absolute laws of physics. The original Apollo engineers faced this exact same brutal mathematics. They had the same rocket equation. They had the same mass limits. So how did they solve the paradox in 1969? They solved it by embracing a level of terrifying risk that our modern society finds completely and utterly unacceptable. The men who designed the Apollo hardware knew they could not afford to build perfect, redundant safety systems. They simply did not have the weight budget. So, they made a dark, calculated decision. They built the absolute bare minimum required to keep the astronauts alive, and they accepted the terrifying reality that the crew might simply die. When Neil Armstrong and Buzz Aldrin strapped themselves into the Saturn V rocket, the internal, private documents of the space agency estimated that there was a roughly 1 in 5 chance they would be completely lost, a 20% chance of absolute, fatal disaster. They flew without complete backup systems. They flew with paper-thin metal walls. They flew knowing that if a single engine valve stuck open for just 1 extra second, they would either burn alive in the atmosphere or drift into the eternal blackness of the solar system. They accepted the chaos. They rolled the cosmic dice. But today, human civilization has fundamentally changed. We live in an era of extreme, absolute safety. The modern space agency is deeply terrified of risk. The political and public relations fallout of losing a crew of highly diverse, celebrated astronauts on live high-definition television would instantly, permanently destroy the entire agency. The modern mandate is absolute perfection, zero loss of life, complete, undeniable safety. Every system must have a backup. Every backup must have a secondary backup. Every single possible failure must be heavily calculated, heavily armored, and completely neutralized. But the universe does not allow absolute perfection. The universe is inherently violent, deeply chaotic, and physically unforgiving. By demanding 100% safety, we have unintentionally built spacecraft that are simply too heavy, too delicate, and entirely too complex to actually fly. We have trapped ourselves behind an invisible wall of our own making. The delay of the Artemis landing is not a temporary setback. It is the chilling realization that our modern philosophy of absolute caution is completely incompatible with the brutal, crude violence required to conquer deep space. Physics is currently forcing the engineers to make an impossible choice. They must either fundamentally redesign the entire architecture of the heat shield, throwing away years of work and billions of dollars, or they must look into the cameras and finally admit to the public that going back to the moon requires a willingness to die. And as the years slip by, and the launch dates are quietly pushed further and further into the shadows, a much larger, more terrifying existential question begins to cast a long, dark shadow over the entire human species. If we are struggling this much, if we are mathematically paralyzed just trying to cross the tiny, shallow pond to our closest neighbor, what does that mean for our grand, sweeping dreams of colonizing the entire solar system? What does this terrifying barrier mean for the ultimate survival of humanity? If we are mathematically and biologically paralyzed, just trying to cross the incredibly tiny, shallow pond to our closest neighbor, what does that mean for our grand, sweeping dreams of colonizing the entire solar system? For decades, we have been sold a very specific, highly optimistic vision of our future. We have been told that reaching the moon again with the Artemis program is just a simple stepping stone, a temporary practice run. The ultimate, glorious goal has always been the red planet, Mars. We see the beautiful digital animations of massive silver rockets landing gracefully on the dusty red dunes. We see massive glass domes filled with green plants and smiling human colonists. We treat Mars as if it is simply the next logical real estate development. But when you take the terrifying physical barrier we just discovered between the Earth and the Moon, and you project it outward toward Mars, the dream of human colonization begins to look less like an inevitable triumph and much more like a biological suicide mission. The Moon is roughly 238,000 miles away. A spacecraft can cross that distance in about 3 days. Mars, on average, is 140 million miles away. That is not just a longer trip, it is a completely different dimension of travel. Depending on the exact alignment of the planets, a one-way trip to Mars takes roughly 7 to 9 entire months of continuous, non-stop flight through the deepest, darkest parts of the cosmic ocean. If the journey to the Moon is like holding your breath and running quickly across your front lawn, the journey to Mars is like trying to swim across the entire Pacific Ocean with absolutely no life jacket, blindfolded, in the middle of a raging hurricane. During those 7 long months, the spacecraft is completely out in the open. There is absolutely no magnetic bunker to protect you. The massive, lethal solar storms that we talked about earlier, on a 9-month timeline, they are no longer just a rare, unfortunate possibility. They are an absolute, mathematical guarantee. The sun will aggressively fire off multiple waves of intense, boiling radiation directly into the path of the ship, and you cannot build a heat shield thick enough to stop it, because we already proved that our rockets simply cannot lift that much weight. But even if you somehow manage to magically armor the ship against the violent solar wind, you immediately crash into a completely different, deeply horrifying biological wall. We talked about how space breaks our complex digital computers, but space is equally talented at systematically dismantling the human body. Down here on Earth, we take the heavy, invisible pull of gravity completely for granted. We think of it as just the force that keeps our feet glued to the floor. But human biology is incredibly responsive. Your entire body is essentially a living, breathing machine that was custom-built over millions of years of evolution to operate precisely under the crushing weight of one Earth gravity. When you take that weight away, when you float in the absolute zero gravity of deep space for months at a time, the body does not just relax, it completely panics. Without the constant, heavy physical stress of walking and carrying your own weight, your bones fundamentally change their behavior. The human skeleton is not just a static frame of dead white sticks. It is a highly active, living tissue that constantly destroys and rebuilds itself based on the pressure it feels. In the silence of microgravity, your skeleton assumes you no longer need it. Your body immediately begins to violently, aggressively dismantle your bones. It strips the vital calcium straight out of your skeletal structure and dumps it directly into your bloodstream. Your bones become deeply porous, incredibly brittle, and dangerously weak. At the same time, the human heart, which usually has to pump blood aggressively uphill against gravity to reach your brain, suddenly has nothing to fight against. Without that resistance, the heart muscle begins to rapidly shrink. It becomes incredibly weak and highly inefficient. The fluids inside your body, which are normally pulled down into your legs, violently rush up into your chest and your head. The faces of astronauts become permanently swollen. But the most terrifying consequence of this fluid shift happens entirely in the dark, right behind the eyes. The excess fluid actively crushes the optic nerves. It flattens the back of the eyeballs. Astronauts who spend long durations in space frequently experience a terrifying, permanent degradation of their physical vision. They slowly, quietly begin to go blind. Now, imagine an Artemis crew surviving a 9-month journey of absolute biological degradation. Their bones are physically dissolving, their hearts are weak, their vision is entirely blurred, their DNA is severely fractured by the relentless bombardment of ancient cosmic rays. And then, they finally arrive at Mars. They do not get a hospital. They do not get a team of specialized doctors to help them recover. Instead, they immediately have to strap themselves into their seats and endure the most violent, terrifying, atmospheric entry ever attempted, followed by grueling, heavy physical labor on a hostile, freezing red desert. The absolute, cold truth that the space industry quietly whispers in the shadows is that we simply do not know if a human being can actually survive that timeline. The human body might literally not be designed to leave the immediate vicinity of this planet. And this biological nightmare brings us to the ultimate, most terrifying psychological barrier of all: the latency of human connection. When the Apollo astronauts walked on the moon, they could talk to mission control in Houston. There was a brief delay of about 1.5 seconds each way, just enough to be slightly annoying, but fast enough to maintain a real, flowing conversation. But space is entirely too big for real-time communication. The speed of light is the absolute, unbreakable speed limit of the universe. When a spacecraft reaches the orbit of Mars, the distance is so incredibly vast that a radio signal, traveling at the absolute maximum speed allowed by the laws of physics, takes up to 20 entire minutes just to reach the Earth. If a catastrophic fire suddenly breaks out in the life support system of the Mars spacecraft, the crew would desperately shout into their microphones for help. That desperate cry for help would travel through the silent void for 20 agonizing minutes. When Mission Control finally hears the message, they would immediately shout the solution back into their microphones, and that answer would take another 20 minutes to travel back to the dying ship. 40 entire minutes of absolute, deafening silence for a single exchange of words. You cannot have a conversation. You cannot receive active help. You are fundamentally, completely severed from the human race. Imagine the sheer, crushing, psychological terror of looking out the small, thick window of the spacecraft. When you are in low orbit, the Earth fills your entire view. It is massive, bright, and deeply comforting. Even on the Moon, the Earth is a large, beautiful blue marble hanging permanently in the black sky. But from the surface of Mars, the Earth is completely gone. It is no longer a world. It is no longer a recognizable place. It is just a tiny, pale blue speck of light, a completely anonymous, insignificant star lost entirely against the overwhelming darkness of the deep universe. You cannot see the oceans. You cannot see the clouds. You cannot see the billions of people living their lives. Every human being who has ever lived, every historical event, every person you have ever loved, is contained on a tiny dot of light so incredibly small that you could completely erase it from your vision just by holding up your thumb. This terrifying phenomenon is known as the Earth out of view problem. Psychologists do not know if the human mind can actually handle that level of absolute, infinite isolation. We evolved to feel connected to our environment. When you physically erase the entire planet of your birth from your field of vision, the human brain might simply fracture under the weight of the profound loneliness. When you add all of these terrifying barriers together, the impossible tyranny of the rocket equation, the lethal oceans of deep space radiation, the terrifying fragility of modern microchips, the physical dissolving of human bones, and the agonizing psychological severance of distance, a very dark, deeply unsettling philosophical theory begins to emerge. For decades, astronomers have pointed their massive, highly advanced telescopes at the night sky. They have scanned millions of distant stars. They have listened carefully to the radio frequencies of the galaxy, and they have found absolutely nothing. The universe is completely, deafeningly silent. We see no massive alien empires. We hear no cosmic radio broadcasts. We see no signs of biological life spreading across the stars. This terrifying silence is one of the greatest mysteries in all of modern science. If the universe is incredibly old, and there are billions of planets just like ours, where is everybody else? Perhaps the delay of the Artemis program is secretly whispering the answer to us. Perhaps the universe is completely silent, because the physics of deep space are simply an impenetrable, permanent quarantine. What if the universe is constantly creating beautiful, lush planets teeming with biological life, but it intentionally designed the vast, empty spaces between those planets to be incredibly, impossibly lethal? The cosmic radiation, the crushing distances, and the brutal laws of mass and gravity might not be engineering puzzles meant to be solved. They might be a deliberate, absolute physical cage, a cage designed to ensure that biological life, no matter how intelligent, no matter how ambitious, can never truly leave the specific rock it was born on. We look up at the stars and we see a grand open frontier waiting to be conquered. We see a vast ocean waiting for our silver ships. But maybe the universe does not see us as explorers. Maybe the cold, uncaring physics of the cosmos look at our tiny metal capsules and our fragile, water-filled bodies, and simply dictates that we belong exactly where we are. The sudden, quiet delays of our modern space programs are not just a failure of supply chains or a lack of government funding. They are the terrifying sound of human ambition crashing violently into the absolute limits of reality. We are finally pushing hard enough against the invisible walls of our terrarium to realize that the glass is incredibly thick, heavily armored, and designed strictly to keep us contained. We built the most powerful rocket in human history purely to discover that the dark void outside our door is actively waiting to tear us apart. And as the years continue to pass, and the promised dates of our grand lunar return slip quietly further into the unknown, we are left to confront a deeply uncomfortable, terrifying possibility. We have spent the last century telling ourselves a very comforting story. We look back at the grand history of human exploration, from the ancient wooden ships crossing the vast oceans, to the early steel airplanes conquering the sky, and we naturally assume that the black ocean of space is simply the next logical chapter in our manifest destiny. We believe that because we have a boundless imagination, the universe must eventually surrender to our engineering. We assume that we are the main characters in a grand cosmic play, destined to walk among the stars and leave our footprints on 1,000 different worlds. But the universe does not share our romantic vision of the future. Think about the creatures that live at the very bottom of the Mariana Trench. They exist in total darkness, surviving under the crushing, impossible pressure of the deep ocean. They are perfectly, beautifully evolved for their extreme environment. But if you take one of those deep-sea creatures and pull it up to the warm, sunlit surface, it does not become an explorer. It violently depressurizes, its biology instantly betrays it, and it dies. We look at those creatures and we understand their absolute biological limit. Yet, when we look at ourselves, we somehow believe we are the magical exception to the rule. We are not the exception. We are deeply, fundamentally tethered to the incredibly specific atmospheric pressure, the magnetic shielding, and the dense gravity of this one specific rock. For decades, we tricked ourselves by staying safely in low Earth orbit. We built space stations just a few hundred miles above our heads and convinced ourselves we were mastering the cosmos. But we were just waiting in the shallow water at the edge of the beach, entirely protected by the invisible magnetic bunker of the Earth. Now, as we finally try to leave the shore and swim back out into the deep, dark water, the terrifying reality of the ocean is pushing back. The sudden stalling of the Artemis program is the exact moment the human race is finally being pulled to the surface, and we are beginning to feel the agonizing burn of depressurization, the delayed rocket launches, the shattered heat shields, and the terrifying biological radiation limits are not just simple engineering hurdles waiting to be neatly solved. They are the cold, hard bars of our cosmic cage. The cosmos is not an inviting frontier. It is an infinitely vast, heavily irradiated wasteland governed by forces so aggressive and absolute that they make our greatest technological achievements look like fragile, meaningless toys. Perhaps we need to stop looking at the night sky as a map of future human colonies. Perhaps the billions of dead, silent planets floating in the void are not quietly waiting for us to arrive. Maybe they are a silent warning. The next time you walk outside on a quiet night and look up at the pale white glow of the moon, do not look at it as a stepping stone. Look at it as the absolute edge of our reality. It is the towering wall of a quarantine zone that we were never meant to cross. We are trapped here, not by a lack of government funding, and not by a lack of human courage. We are trapped by the inescapable, unforgiving laws of physics and the terrifying fragility of our own blood and bone. The universe is completely indifferent to our dreams, and the cold, dark truth is this small, blue terrarium is the only home we will ever know.